So we're in the middle of question number 13 in the Unit 3 practice problem set, and we're looking at part B, find the material's annual decay rate. But instead of finding the annual decay rate first, I'm going to find the annual growth rate, which I expect to be negative. And I'm using this formula, R equals e to the RC minus 1. So we've got second e raised to the negative 0.00872. Be careful not to put an x there. In this case, we don't want the variable. Subtract 1 from that and multiply by 100. And this is my growth rate. This is, and as I said, it's going to be negative. So the actual annual decay rate is positive 0.868%. 0.868%. That's my decay rate. That is my annual decay rate. What about question C, find the materials per decade decay rate? So for that one, we've got to do a little bit more work because we also have a time unit change. I'm going to start by looking at the factor. The yearly factor is e to the negative 0.00872. And now I want to convert this to the decade factor. And to do that, all I have to do is raise this to the 10th power because I'm going from annual to yearly. So this will give me my decade factor. Once I have my decade factor, then I want to go to the decade rate, and that will basically just mean, and I always do this in terms of growth, and then I change the sign because I know that I need decay, but well, this is just the habit that I have. So this is going to be e to the negative 0.00872 to the 10th, and then to turn that back into a rate, we subtract 1 from it, and then finally change the sign and multiply by 100 to put it in percent form. All right, so let's do all of that. So we have, I'll clear the screen. We have second e to the negative 0.00872. And we could go ahead and do multiplied by 10 right here. That's fine. Then subtract 1 from all of that. Multiply by 100. And change the sign. So 8.351% is my decade decay rate. All right. And that's number 13. Moving along to number 14. A savings account has an APR of 1.375% compounded semi-annually. Find the account's continuous annual growth rate. So for this one, we've got a couple of things going on. We have this, we're going to have to use the compounding formula for semi-annual, and then we have to convert this somehow to a continuous rate. So I'm going to begin with the formula for compounded semi-annually. So we don't have an initial value, but just to get started, this would be, let's say we start off with, actually let's just write the formula down. Okay, so that's the old formula, and let's assume that we had 1 unit, since otherwise it's not stated. Our APR is 0.01375, over 2 because it's semi-annual, and that's raised to the 2t. Now, if we want to get the continuous annual growth rate, we need to start with the factor. So I need the factor from all of this. So what is the factor? Well, the factor is just, I can circle it, it's this stuff. And notice that I included the 2, but not the t. So the factor is 1 plus 0.01375 over 2 raised to the 2. And now I need to take that factor, because what I'm trying to get here is, basically it's RC. If you recall, what's the formula to get RC when we have the factor? Well, that's RC is ln of b. And this is b. So really all I have to do here is take the natural log of all of this stuff. And that will give me my continuous annual growth rate. So this is going to be natural log. And I do have kind of a lot going on here. Actually, one thing you could do, you could compute this and then take the natural log of it. Why don't we do that? So that's going to be 0.01375 divided by 2, because there's kind of a lot of steps here. Add 1 to it, so I'm working kind of inside out. Then square it, and then take the natural log of all of that. Oops, and I screwed up, sorry. Natural log of my answer. And then we want to multiply this by 100 to put it in percent form, so we have 1.370%. And that is our continuous annual rate, growth rate. All right, so that's number 14. Let's look at number 15. A bag contains pennies, nickels, dimes, and quarters. There are a total of 278 coins in the bag, and their value is $17.63. There are 3 times as many nickels as quarters. There are the same number of pennies and quarters combined as there are nickels and dimes combined. And we want to know how many of each type of coin are there. So this is obviously a word problem. We're going to need a matrix for this. But first we need to identify the question and the variables. So the question is right here. How many of each type of coin? So that's the thing I'm looking for, is how many dimes, nickels, quarters, and pennies. So that's going to lead me to define my variables as follows. I'm going to use P, N, D, and Q, and you can probably guess why. So P is the number of pennies, N is the number of nickels, and etc. Okay, number of dimes and number of quarters. So what type of information do we have? Well, we have total amount information, we have total value information, and then we've got some other sort of ratio kind of information. So my total amount says that P plus N plus D plus Q equals 283. I'm sorry, no it doesn't. I don't know where I got that. 278. 278 coins. Our total value is going to be the value of each coin times the number of that coin. So for pennies, that would be, the value is 0.01 times P, and that's the total penny value. The total nickel value is 0.05 times N. Total dime value is 0.1 times D. The total quarter value is 0.25 times Q, and altogether that equals $17.63. And that's our value equation. Be careful to not mess these value statements up here. You know, penny is 0.01, dime is 0.1, etc. So we have 2 equations. Now we have 4 variables, so we're going to need 4 equations. So I need 2 more equations. So let's go on to the other 2 statements here. and then we'll put our system together. So it says there are 3 times as many nickels as there are quarters. So that means nickels is bigger than quarters. So Q is the one that needs to get multiplied by something to equal the size of n. So we have 3 times as many. So 3Q equals n. Now we have to change a couple of things here. So we have n minus 3Q equals 0, but we also need to represent the pennies and the dimes. So our final equation for this relationship is going to be 0p. Let's put it in a different color. A little variation here. 0p plus 1n plus 0d minus 3q equals 0. So that'll be equation number 3. And then finally equation 4 is coming from this statement: there are the same number of pennies and quarters combined as there are nickels and dimes combined. So what does that mean? Well, when we say pennies and quarters combined, we just mean adding them together. So if I add the pennies and the quarters, that would be P plus Q. That's equal to the nickels and the dimes, N plus D. So that's our statement, and therefore that's our fourth equation, which we need to arrange. So that would be P plus Q minus N minus D equals 0. But this is also in the wrong order, so finally it's going to be P minus N minus, P minus N minus D plus Q equals 0. And it's kind of messy, but that is our system. This is our system right here. So from that, we need to get a matrix and then solve the matrix. So let me see here. Make myself a little room. I'm gonna temporarily shrink this. My matrix will be 1, 1, 1, 1. This is matrix A of coefficients. Then 0.01, 0.05, 0.1, 0.25, 0, 1, 0, minus 3, and 1, negative 1, negative 1, 1. That's from the fourth equation. So that's kind of a mess, but that's it. And then we'll take the inverse of that and multiply it by matrix of coefficients, which is matrix B, and that will be 278, 17.63, 0, and 0. So that's the system that I'm getting from my 4 linear equations here, if I haven't made any mistakes. I don't think I have. So we'll need to take we'll need a 4 by 4 matrix here, and this is a 4 by 1. And then we'll enter this matrix, and then we take the inverse of it and do our multiplication. I'm going to do some of this off camera now. Okay, so I went off camera and typed in these 2 matrices. As you can see here, this is the B matrix, and I did the A one as well. So now I'm ready to do this multiplication. I call it A inverse, and I multiply it by matrix B. And I get a 4 by 1 matrix. And this is pennies, nickels, dimes, quarters. Pennies, nickels, dimes, quarters. All right. So that's number 13, I think. I'm sorry, no, that's number 15. Number 15. And we'll finish number 16 and 17 in the next video.